Hello and welcome back to Dr. Logic Awkwardly Does Logic. Though I have been told that everything is less awkward with a cat, so I will just have to say hello and welcome to Dr. Logic Does Logic with a cat. We are finally going to talk about the rules of replacement. The rules of replacement differ from all of the other rules that we've seen so far in that both the basic rules and the derived rules I've given you so far can only be applied to an entire formula. So you have to find a complete formula that has the right shape on a particular line in your proof, or sometimes two of them, before you are able to apply one of the rules that we've introduced so far. The rules of replacement, on the other hand, allow you to do exactly that. So you can still work at the level of complete formulas written down on lines of your proof, but you can also do things at the level of subformulas. So what we're going to be doing is replacing either a complete formula or a part of a formula with something that is semantically equivalent to it. So some of the rules are very easy. For instance, double negation takes a formula and adds two negations to it, or a subformula and adds two negations to it, or takes a formula or a subformula and removes two. If think back to the truth conditional for negation. If P is true, then not P is false. But if you put another negation on that again, you get not P, which goes back to true, because you're just flipping back and forth between truth values. So anytime that you have an even number of negations, it has the same truth value as the original formula you started with. So that is the thought behind all of these. We will be taking things that are semantically equivalent to each other and replacing them. So when I start writing these rules out, I'm not going to be able to give you the same sort of schematic diagram that I did for the other rules, because it's really hard to say something like, if you have some line on your proof that has some subformula of this type in at least one place. So these rules are just going to be written out in words. However, I will give a couple of examples so that you can see what the application of these rules look like in practice. They are basically exactly the same as the other rules that we've seen, just with this added bit that you can do it at the level of subformulas, not at the level of main formulas. So let me bring up my whiteboard. Come on, there we go, and make it full screen. So hopefully we don't have any problems with recording. The four rules of replacement that I'm going to introduce to you are contraposition, which is going to look a lot like modus tollens, and double negation, which I've already just mentioned. We are going to introduce rules that correspond to DeMorgan's laws. And you are going to get one more called exportation, which has to do with conditionals and conjunctions and relations between them. So let's take a look at contraposition first. Contraposition says, so I'm just going to give the abbreviation for it, contra, that's good enough. If you have on line I of a proof a conditional of the form phi implies psi, either as a with, or, and this is the part that is special to the laws of replacement, or as a subformula, then you can replace it on line n with not psi implies not phi. So now you can see how this is like modus tollens. Instead of just saying from phi implies psi and not psi, you can derive not phi. You can just go straight from, if phi implies psi, then you already know that not psi implies not phi. And because these are rules of replacement, you can always do it the other way around. So, and vice versa. So if you have not psi implies not phi on some line of your proof, either as a well-formed formula or as a subformula of one, then you can replace it with phi implies psi. And then we'll have with justification, contraposition, citing line I. So before I give you the other rules, I'm going to give you an example, and it's going to be two different ways that we can apply the contraposition rule. So suppose we've got our proof that has phi implies psi on, or sorry, no, that's not what I want. I want phi implies, there we go, psi implies gamma. So I want this slightly more complicated conditional. Don't know how I got it, but we have some annotation for it. Suppose this is what we have. Then, say on line M, I can take the antecedent and the consequent of a conditional. I can reverse them so that the antecedent becomes the consequent and the consequent the antecedent, and put negations on both of them. Now here in line I have two conditionals. So I can do this on either one. So if we were just going to treat this like an ordinary rule and apply it to the main connective, what this would get me is that not psi implies gamma implies not phi. So this is contraposition, line I, where this is my consequent, this is my antecedent. I swap the two and I put negations on both. But because this is a rule of replacement and I can operate at the level of subformulas, I can also do it on this one here. So let's do that here at line N. So the antecedent remains unchanged. I'm just doing contraposition on this. So that gets me not gamma implies not psi. And this has exactly the same justification as line M. So there you go. I hope that having this example helps you to see the different ways in which you can apply the rules of replacement. So the next one is double negation, is very easy. So if you have a with or subformula phi on line I of a proof, then you can write down not phi. So you can, let me not state it that way. You can, help. Let's see, here we go. We've got a whip back. So double negation. If you have a well-formed formula or subformula phi on line I of a proof, then you can replace it with not phi on line N, or vice versa. So you can go from the double negated form to the form without the negation. And this is with justification, double negation, line I. Same justification whether you're adding the negations or removing them. DeMorgan's laws, if you remember back to when we were proving some semantic equivalences, we showed that there was this intimate relation between negated conjunctions and disjunctions of negations on the one hand, and negated disjunctions and conjunctions of negations on the other. The DeMorgan's rule is just making explicit these semantically equivalent laws that we showed earlier and codifying them into a kind of a one-step process. So this means that there's two versions. There's one for the negated conjunctions and one for the negated disjunctions. So the first one is if you have not phi and psi as a with or subformula on line I of a proof, you can write down not phi, or, sorry, I really should be being more explicit here, because I really want to make it clear, make you remember that these are replacement rules. So you can replace it with not phi or not psi on line n, or vice versa with justification, DeMorgan's line I. And the second version says if you have not phi or psi as a width or subformula on line I of a proof, you can replace it with not phi and not psi on line n, or vice versa with justification, DeMorgan's line I. Now, I am running out of room on the whiteboard for exportation, but let's see if we can fit it in. Exportation says that if you have something of the form phi implies psi implies gamma, as I'm just going to skip some of the same verbiage, but just it's there. I'm just going to say it rather than write it down so that we've got space to get everything. So as a width or a subformula on line I of a proof, it can be replaced with phi and psi together imply gamma. And you can do this on line n, or vice versa with justification. You can just write down exp instead of exportation on line I. So all of these are replacement rules. Anytime that you see a formula or subformula that has one of these forms, you can replace it with the other one, keeping everything else in the formula unchanged, and justify it with reference to one of these 4 rules of replacement. As with all of the proof rules, they become a lot easier to understand once you actually see them in action. And once you see them in action, you will start saying, oh, these will make my life so much easier. So next time, I'm going to give you some examples of proofs that use these rules, perhaps also with showing what it would be like trying to prove the same things without, and you will see just how much simpler these will make it for you. So I hope to see you back then. Take care. Cheers.